Hi everyone, we're going to evaluate the given integral using inverse substitution with trig functions. Mainly, we're going to use this table of trigonometric substitutions. So, I forgot to write this down again, so let me write this down. Basically, this form here, when you have these radicals, has this expression here. So we're going to make this kind of substitution. We're going to let x equal, and our a in our case is going to be 2 tan of theta. And this is going to be restricted from negative pi divided by 2 to pi divided by 2. That means quadrant 4 and 2. So dx is going to equal 2 secant squared theta, d theta. Now, just dealing with this piece here, let's substitute in our x. So we're going to get 4 tan squared theta plus 4, which equals the square root of 4 times tan squared theta plus 1. Now, this equals secant. So you get square root of 4 secant squared theta, which equals 2 secant theta. Usually you put the absolute value signs on, but because we're, cosine is positive in quadrants 1 to 4, or 4 to 1, we can take the absolute value signs off. Now we can do our substitution, and when you do that, we're going to have dx, which is going to just be 2 secant squared theta d theta, and x squared, so square this. That's going to be 4 tan squared theta. And then this piece here we already did, which was times 2 secant theta. Now all we have to do is simplify this. We have these two cancel. So we get 1/4. Pull that out. And we have some secants. This cancels with that one time. So that's just going to be secant theta. And then we still have our tan squared theta, d theta. Now, to evaluate this, let's write this in terms of sine and cosine. So this is basically 1 over cosine times, I'm going to flip this cosine squared over sine squared. So basically this goes into that one time, so you're going to get 1/4 times the integral of cosine theta over sine squared theta d theta. It makes it easier to substitute with u substitution. So let's write that out. We have the integral 1/4 of cosine theta sine squared theta d theta. And let's let u equal sine of theta. That means d u would be cosine of theta. So let's just do that substitution. We're going to get 1/4 equals du, which is our cosine. Oops, we should have d theta here. Sorry about that. So it takes care of that piece. And then sine squared is just going to be u squared. So that gives you 1/4. And this is just going to be negative 1u plus c. So substitute back in your sine. So that's going to be 1/4 negative, put the negative out here, 1 over sine plus c. That's going to be basically negative 1 divided by, well, let's just write this as cosecant. So it's going to be negative cosecant theta divided by 4 plus c. All right, now I'm going to write this again. Negative cosecant theta divided by 4 plus c. Now what we know is we can't leave it in theta because we started with x. So I'm going to put my angle here, and we know that we did our substitution as x equal 2 tan of theta. So tan of theta equals x divided by 2. So that's opposite over adjacent. Opposite, this is opposite over adjacent. When you do the Pythagorean theorem, this hypotenuse is going to be x squared plus 4. Now, to solve for this, we want to know what cosecant of theta is going to equal. We know that cosecant of theta is going to be r over the opposite, or your hypotenuse over the opposite. So that's going to equal square root of x squared plus 4 divided by x. All right, so we can substitute that back in. So that's going to be negative square root of x squared plus 4 divided by x. And we still have this 4, so you can just put it there, plus c. And that's your final answer. Thank you. Have a nice day. Bye-bye.